Hello, this is Mr. Ensler, and I am going to go over the Chapter 7.5 to 7.8 review. This chapter was all about using trigonometry, kind of an intro to trigonometry. And so the first thing we're going to talk about is sine, cosine, and tangent. And to be successful, you really have to know what each of those stand for. You have to know that sine is the opposite over hypotenuse. Cosine is the adjacent over hypotenuse, and tangent is opposite over adjacent. A lot of people put that into a word and say SOHCAHTOA, and they get their test, and the first thing they do is put that on the top so they know what's what. So you're welcome to do that. And these first set of problems, 1, 2, and 3, we're looking at the triangle from the point of view of angle A. So, if we're looking at this from angle A, that's what we're starting with. The sine of angle A is opposite over hypotenuse, so 56 would be the opposite. 56 the opposite. 65 is the hypotenuse, and when we get to it, 33 is the adjacent, because it's right next to the angle, but it's not the hypotenuse. So sine, opposite over hypotenuse, 56 over 65. Now, you want to try to simplify that fraction. Can you divide 56 and 65 by any of the same numbers? Can you just reduce this fraction? So you can look for that. A shortcut that I showed you on our calculators is to enter in 56, and then you'll press the fraction button, which is this A, B over C button, and then 65, and then press enter. And if that fraction can reduce, it will reduce it for you. Actually, in this case, it can't reduce. That's as simple as it's going to get. Then we actually want to divide 56 by 65. So you'll enter in 56 divided by 65. That way, we can get a decimal approximation. Sometimes we want an exact value, so we leave it as a fraction, but sometimes it's more useful to us to get an approximation of it. So you'll enter in 56 divided by 65, and you got to round to 4 places, so that would be 0.8615. Okay, let's go to cosine of A. So cosine is adjacent over hypotenuse. So from A's point of view, that's 33 over 65. And you try to reduce 33 over 65, but it actually doesn't reduce. So you just type that in, 33 divided by 65. If we round that, we should get 0.507. And then the last digit would round up to a 7, so 0.5077. Okay, tangent of A. From A's point of view, tangent is opposite over adjacent, so 56 over 33. And like the others, this can't really reduce, so you'll just divide 56 divided by 33. And when we round that, we get 1.6970 is what that would round to. Okay, now we're going to deal with the same triangle, but from the point of view of angle B. So I'm going to go and change some things here. We're no longer looking at it from angle A's point of view. So if you made any markings on your paper, you want to cross those off or erase them because they're going to be different, most of them. If we're looking at it from B's point of view, 65 is still the hypotenuse, so I guess that doesn't change. The hypotenuse of a right triangle, that's always just going to be the same. But the adjacent and opposite are going to be different numbers now. What's the side that's right next to angle B? That would be 56. That's the adjacent side. What is opposite from angle B? That's 33. So the adjacent and opposite, it depends what angle you're looking from. So now we'll use that information to do angle B. So sine is opposite over hypotenuse. So opposite over hypotenuse is 33 over 65. We know that doesn't reduce. And when you divide that, you get 0.5077, approximately. All right, cosine of angle B is adjacent over hypotenuse. So 56 over 65, that is already reduced. And so when you round that out, you get 0.8615. Lastly, we have tangent of angle B. Tangent, we know, is opposite over adjacent. And so from B's point of view, that would be 33 over 56. And 33 over 56, that can't reduce. If you divide it, you get 0.589, and the last digit would be 3. Now some of you have noticed something here. Look at the sine of A, 56 over 65, 0.8615. Look at the cosine of B. They are identical. Yeah, that will happen. If you're taking the sine, cosine, tangent of both angles, you will notice some of them are the same. You don't have to memorize that or do anything with it. Just don't be thrown off by it. Okay, here we have another one. And we're going from A's point of view to begin with. So 15 is the hypotenuse. 9 would be the opposite side, and 12 is the adjacent side. So sine is opposite over hypotenuse, 9 over 15. And that can reduce. They both divide by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. Or again, just enter it into your fraction, enter it into your calculator as 9 fraction 15, and that's what it will reduce to. When you divide 3 divided by 5, actually you don't need to round, it just comes out exactly to 0.6. So if you don't need to do all 4 places, that's fine. This just comes out evenly. Alright, cosine of A. So cosine is adjacent over hypotenuse, so 12 over 15. And that will reduce also. 12 over 15 is 4/5. If you divide that out, you get 0.8. No need to round there. Alright, tangent of A. Tangent is opposite over adjacent, so 9 over 12. 9 over 12, that can reduce. Divide them both by 3 and you get 3/4. And that will reduce to 0.75. No need to round there. Okay, now we got to change our point of view because now we're looking at it from angle B. So I need to go back and erase some of these things. Okay, so now we're going to look at this triangle from angle B's point of view. 15 is still the hypotenuse, but now 12 is the opposite side and 9 is the adjacent side. So it depends what angle you're looking from. So the sine of B, sine is opposite over hypotenuse, that'd be 12 over 15. And you can reduce that to 4/5. And if you divide 4 divided by 5, you get 0.8. Again, no need to round. You might remember that the sine of one angle is going to be the cosine of the other angle. Alright, the cosine of angle B. So from B's point of view, cosine is adjacent over hypotenuse, 9 over 15. And 9 over 15, that reduces to 3/5, or just 0.6. We want you to have both of those answers. Alright, tangent. Tangent of an angle is opposite over adjacent. So this will be 12 over 9. And 12 over 9, if you reduce that, you get 4/3. If you type in 4 divided by 3 into your calculator, that's not going to come out quite evenly. You get 1 and 1/3, so either 1.3 repeating or, since we're just rounding to 4 decimals, 1.3333. Okay, So that's kind of just explaining what sine, cosine, and tangent are. Now let's use those to solve these problems. We can figure out a side or an angle of a triangle. So in number 13, we're going to be looking at this from 62's point of view. So 25 would be the adjacent, x would be the opposite. And this other side over here is the hypotenuse, but we're not going to use that here. So you've heard me say in class, you need to know your sine, cosine, and tangent forwards and backwards. This is what I mean by backwards. You might be able to define what are sine, cosine, tangent, but can you do it in reverse? If I give you adjacent and opposite, do you know which function, sine, cosine, or tangent, that is? So if you go up to what we talked about before, adjacent and opposite, that would be tangent. So what you would do here is you would set this up as tangent of 62 equals opposite over adjacent, so x over 25. Now, we need to figure out what x is, so we are not done. In order to get x by itself, what we can do is multiply both sides by 25. The reason why that works is because right now x is dividing by 25, so multiplying by it will cancel that out. And so what you're going to type into your calculator is this right here, 25 times tangent 62. And when you type that in, or round into one decimal place, you should get 47.0. We'll just round to one decimal place. Okay, and that's that problem. You're only just doing one thing at a time here. Let's go on to number 14. All right, number 14, we are looking at this from 47 degrees point of view. So 12 is the hypotenuse, x is the adjacent, so you need to know which one, sine, cosine, or tangent, uses hypotenuse and adjacent, and it's cosine. So cosine of 47 degrees equals adjacent over hypotenuse, so x over 12. X is dividing by 12, so to get x totally by itself, we're going to multiply by 12 on both sides. It'll cancel out next to the x, so that the x will be by itself. It won't cancel out on the other side. On the other side, you just actually have to multiply that. You'll type in 12 times cosine 47. So it turns out this missing side value, x, is 8.2. If we round that correctly, you should get 8.2. All right, number 15. So here we're looking at this from 32 degrees point of view. So 18 is the hypotenuse, and x is the opposite. So which function involves hypotenuse and opposite? That would be sine. So I can say sine of 32 degrees is opposite over hypotenuse, so x over 18. X is on top, again, that's kind of nice. And so to get the x by itself, we'll multiply both sides by 18. I'll cancel out over here, and so you'll just type into your calculator 18 times sine 32. And you should get 9.5. All right, number 16. What do we have here? We have 34 degrees. 15 is adjacent. X is opposite. So which function uses those two? Tangent. So we'll say tangent 34 degrees. Tangent is opposite over adjacent, so x over 15. The order does matter. You got to put the correct one on top, the correct one on bottom. To get the x by itself, we will again multiply both sides. We'll multiply by 15. And so you'll type that into your calculator, 15 times tangent 34. And you get 10.1, so x is approximately equal to 10.1. All right, let's go to the next page. Okay, we are doing the same thing that we were doing before on the first page. The only difference here is that there might be more than one variable. It says find the value of the variables. So like in number 17, I have to find t and u. And just a note, there are many, many different ways that you could come up with these answers. The ways that I'm showing you are just one way. So feel free to use these ways. All right, I try to use what's given as much as possible. So if I'm looking at this from 51 degrees point of view, 32 is the hypotenuse, u is the adjacent, and t is the opposite. And remember, though, that opposite and adjacent, it changes if you look at it from another angle. So if I were to look at it from this angle, then these would be different. But I'm just going to look at it from 51 degrees point of view. So we have opposite and adjacent. All right, now you would not want to do tangent here. Here's why. Tangent is opposite over adjacent. And we don't know what the opposite is, it's just t. We don't know what the adjacent is, it's just u. And you're not going to be able to solve that equation that has two unknowns in it. So we won't do that. Let me get rid of that. What we'll need to do is use 51 degrees. We'll need to use the hypotenuse 32, and then either one of these, just one at a time. So I'll use 51, opposite, and hypotenuse. Which function has opposite and hypotenuse? That would be sine. So I'll start off by saying sine of 51 degrees is opposite, which is t, over hypotenuse, which is 32. And to get the variable by itself, I'll multiply both sides by 32. And so my answer t, my first answer, will be whatever 32 times sine of 51 equals. And when I type that in, I get 24.9. Okay, now since I already started with 51 degrees, why don't I do another one with 51 degrees? This time I'll use the hypotenuse and the adjacent. And it's the cosine function that uses adjacent over hypotenuse. So that's what I'll do. Cosine of 51 degrees equals adjacent, which is u, over hypotenuse, which is 32. To get that u by itself, we'll need to multiply both sides by 32. And then you'll just type into your calculator 32 times cosine 51. And you should get 20.1 degrees. Or it's not degrees, just 20.1, excuse me. And there's our problem. Okay, let's go to number 18. We just have an x here. So if I want to use 23 degrees, x would be the opposite side, and 53 would be the adjacent side. So that's tangent. So I'll do tangent 23 equals opposite over adjacent, so x over 53. And to get that x by itself, once again, we're going to multiply. We multiply because x is dividing, and when you multiply, that will cancel it out. We will see some problems where you're going to do something else. But so far, that's all we've done. So, all right, I'll go ahead and type this in. 53 times tangent of 23 degrees. And I get 22.5. And there's only one variable with that problem, so we're done. Okay. Number 19. All right, I got to find both r and s. And I'm going to be using 36 degrees. So, again, you just have to pick two sides to use. If we're going to use 36 degrees, 21 is the opposite. S is the hypotenuse. So you could just start with those. Let's see here. Which function has both opposite and hypotenuse? That would be sine. The sine of 36 degrees is opposite over hypotenuse. So 21 over s. And this one's different because the variable is in the denominator. It's in the bottom. You might remember what we've talked about in class, how in this situation, you can just switch places with the sine 36. So it's going to look like this. S will now be by itself, and it will equal 21 divided by sine of 36 degrees. All right? And so you just type that in. We can talk about why that works, but first thing to know is just that it does work, and it's a very convenient shortcut. I get 35.7, so side S is approximately 35.7. Okay. Now let's find r. So I'm still going to use 36 degrees. R would be the adjacent. And so if I use the adjacent and the opposite, which I know, that would be tangent. So I will do tangent 36 degrees equals opposite over adjacent. All right, we're in the same situation where we have this variable on the bottom. Let's talk about why you can just switch places. If you didn't want to take the shortcut like I was just showing you, what you would have to do to get that r out of the denominator, you would have to multiply both sides by r. So you'd actually cancel out the r itself, and then it would basically just move to the other side. All right, so I'm going to rewrite that. I would then have r times tangent 36 degrees equals 21. Now, to get the r by itself, you would need to divide by tangent 36 on both sides. And that way, on the left side, that will cancel. And so you are left with r equals 21 over tangent 36. And so you see how what basically happens is, from the original, these two switch places. And we're just left with r by itself. So let's go ahead and just type that in. 21 divided by tangent of 36, and I get 28.9. So r is approximately 28.9. Okay, on to the next one. Number 20. All right, we have a C and a D, and we're going to look at this from 41 degrees point of view. So D would be the hypotenuse, 17 is the opposite, and C is the adjacent. All right, so I'm going to start off by looking at the adjacent and the opposite. And which function is adjacent and opposite? That would be tangent. So I'll do tangent 41 degrees equals opposite, which is 17, over adjacent, which is C. All right, here we go. Our variable is in the denominator again, so we're going to have these switch places. So we'll just have C equals 17. And this whole thing, tangent 41, now moves to the bottom. And we'll just go ahead and type that into the calculator, 17 divided by tangent of 41 degrees. And you should get 19.6. C is approximately equal to 19.6. Okay, so now I know what C is. Let's do D. And so if I do opposite and hypotenuse, that would be the sine function. So I'll do sine of 41 equals opposite over hypotenuse. Again, our variable is on the bottom of the fraction, so we're going to make this switch. D is going to equal 17 over sine of 41 degrees. And I'll type that in. And that equals 25.9. So D is approximately 25.9. All right. Number 21. We just have a single x there. And using what's given, x would be the adjacent to 43. And 36 is the opposite. So by now you should know that would be tangent. The tangent of an angle is opposite over adjacent. So tangent of 43 is 36 over x. X is on the bottom, so I'll make the switch. So we'll say x equals 36 over tangent 43. And when you type that in, you should get 33.6. Okay, and the last one from this set, number 22. We have both an A and a B, and we're going to be looking at this from 57 degrees point of view. So A is the adjacent, B is the hypotenuse, and 14 is the opposite. So you might be able to tell, now that we've set this up, that if we're using 57 degrees, if we want to use adjacent and opposite, that would be tangent 57. So we'll do that. And if we wanted to do opposite and hypotenuse, that would be sine. So we'll also do that. Doesn't matter what order you do them in, but that's probably how I would solve this. So I'll go ahead and start off with tangent 57. And that's opposite over adjacent, so 14 over a. Since a is on the bottom, we'll make this switch. And we'll have 14 over tangent 57 degrees. All right, and we'll go ahead and type that in. And I get 9.1, approximately 9.1. Okay, and then like I said, let's also do the sine, because we also have opposite and hypotenuse from 57 degrees. So opposite is 14, hypotenuse is b. Again, I'm going to make this switch. So b equals 14 over sine of 57, and that I can just type right in. 14 divided by sine 57, I get 16.7. So b is approximately 16.7. Now, the last few problems I've done, I've just used the given information. I haven't figured out anything more than I needed to. But we could have done these problems a different way. For instance, in number 22 that we just did, I could have figured out what this angle is and set up sine, cosine, or tangent from this angle's point of view. And then, the adjacent and opposite wouldn't be how I've marked it. So there are other ways to do these problems. Okay, on to the next set. You notice in the next several problems, including on the next page, we are finding the value of the angle. Now, sometimes when you find the value of the angle, you can just subtract all of the angles from 180 in order to figure that out, because there's 180 degrees in a triangle. But like in this case, number 23, you can't do that, because this is 90, these two add up to 90, but you don't know what either one of them is. So what you're going to do is you're going to kind of start this the same way. You're going to look at this from A's point of view. 20 is the adjacent, and 30 is the opposite. So which function has both adjacent and opposite? Tangent. So the tangent of angle A is 30 over 20. All right. Now, what is angle A? That's what we need. And so if you remember, this is where we're going to use inverse tangent. On your calculator, it has the little -1 there. So we're going to say inverse tangent 30 over 20. It's like you're asking the calculator, what is the degree of the angle that has a tangent of 30 over 20? And so you go ahead and type that in. And it says 56.3. So the measure of angle A is approximately 56.3 degrees. Now, if I needed to figure out angle C, I could easily do that. I could do 180 minus 90 minus 56.3, or I know these two add up to 90, so I could also just do 90 minus 56.3, and that would tell me this angle. But in this case, you just have to find A. All right, here's another one. We're just finding A. So from A's point of view, this is the hypotenuse, this is the opposite. So which function involves opposite and hypotenuse? That would be sine. The sine of A is opposite over hypotenuse, 14 over 26. What is A? Well, for that, you have to do the inverse sine. So we'll do inverse sine of 14 divided by 26. It's like we're saying, what angle has a sine of 14 over 26? And you should get 32.6. So the measure of angle A is 32.6 degrees. Okay. All right, we have a bunch of other problems where you're just finding the angle A. So again, if you're looking for an angle, either you can subtract from 90 or from 180 and get it pretty quickly, or you're going to have to do an inverse sine, cosine, or tangent. So you can see with a lot of these, that's what we're going to have to do. So if we're looking at angle A, we have the hypotenuse is given, and so is the opposite. Which function is hypotenuse and opposite? It would be sine. So sine of A is opposite over hypotenuse, 7 over 11. So we want to know, what is the angle that has a sine of 7 over 11? So that's what we're going to enter into our calculator. Inverse sine of 7 over 11. And we will figure out that the measure of angle A is approximately 39.5 degrees. Okay, number 28. From A's point of view, we have hypotenuse, and we have adjacent. So you see, you really got to know your sine, cosine, tangent. We use it in almost everything we do this lesson. Which function uses hypotenuse and adjacent? That would be cosine. So cosine of angle A is adjacent over hypotenuse. And so we want to know what is the angle with a cosine of 10 over 16. So inverse cosine of 10 over 16 is 51.3. So measure of angle A is approximately 51.3 degrees. All right, number 29. From A's point of view, we have hypotenuse and we have adjacent. So this will be another cosine. Cosine of A is 6 over 10. What is A? Well, for that, you have to do the inverse cosine of 6 over 10. And that will tell us that the measure of angle A is 53.1 degrees. Number 30. From A's point of view, we have adjacent and we have opposite. So which function uses adjacent and opposite? That would be tangent. So tangent of A, and the order is opposite over adjacent, so 9 over 12. And we want to know what is the angle. What is the angle that has a tangent of 9 over 12? So we're going to do inverse tangent of 9 over 12. And that will tell us what angle A equals. So inverse tangent, 9 divided by 12, and we get 36.9 degrees. All right, number 31. From A's point of view, we have adjacent and we have opposite. Oh, another tangent. So we can say tangent of A is opposite over adjacent, 16 over 20. So inverse tangent is what we want to do. So inverse tangent, 16 divided by 20. And that tells me that the measure of angle A equals 38.7 degrees. All right, the last one from this set. Looking at angle A, we have adjacent and we have opposite, another tangent. So the tangent of A is opposite over adjacent, 37 over 29. So then we'll do inverse tangent, 37 over 29. We're asking the calculator, what angle has a tangent of 37 over 29? If you type that in, you should get 51.9 degrees. All right, next up we have some word problems. During the first part of this unit, we did a lot of applications of the things we've learned. So let's take a look at this first one, 33. You're 50 feet from the screen at a drive-in movie. The angle of elevation to the top of the screen is 58 degrees. How tall is the screen? Well, it might be helpful to draw a picture. So when it says you are 50 feet from the screen, that's just going to be a straight horizontal distance. All right. The angle of elevation, that means the angle as you look up. So the angle as you look up is 58 degrees. So this is a length of 50, and the angle as you look up is 58 degrees. All right, and the question is, how tall is the screen? Well, here's the screen, and so you can see we have a right angle, assuming that they're not showing you a crooked movie. The screen rises straight up. All right, so you can call that X or whatever you want. So just like the ones that we did above, now we just need to do a sine, cosine, or tangent. Looking at this from 58 degrees point of view, we have opposite and adjacent. which is tangent. So I'll do tangent 58 degrees equals x over 50. We need to get that x by itself, so we'll multiply both sides by 50. That way the x will be by itself. And we'll type in 50 times tangent 58. And it doesn't say what to round to, but if we just continue what we have been rounding to the nearest tenth, I get 80.0 feet. So that would be our answer. And that's reasonable. All right, number 34. You lean a 20-foot ladder against a wall. All right, well that you can probably draw. Here's the wall. Here is the 20-foot ladder. So this time the diagonal is 20 feet. The base of the ladder, that's right here, is 4 feet from the wall. So that would mean this is 4. I don't think I've drawn this very accurately to scale. That's okay though. Now, yeah, we're assuming that this wall is standing straight up. Most walls are at 90 degrees. So we want to know, what angle does the ladder make with the ground? We want to know, what is this angle? You can give that a letter if you want. You can call it angle x. And so, which are we going to be dealing with, sine, cosine, or tangent? Well, we have hypotenuse and we have adjacent. So, which function involves hypotenuse and adjacent? It is cosine. So the cosine of our angle is adjacent over hypotenuse, 4 over 20. What we want to know is, what is that angle? So we're going to have to use an inverse. We're going to ask our calculator, what is the angle that has a cosine of 4 divided by 20? And if we type that in, it says that the angle is 78.5 degrees. That would make sense, 78.5 degrees. All right, a chairlift on a ski slope has an angle of elevation of 28 degrees and covers a total distance of 4,640 feet. So this is the angle going up at 28 degrees with the ground. So that's supposed to be a straight line there. And we want to know, what is the vertical height? So the vertical height, which is at a 90-degree angle, and the ski slope has an angle that covers a total distance of 4,640 feet. Now, I think this question is a little bit ambiguously phrased, because the 4,640 feet, is that the diagonal distance, or is that the horizontal distance, I guess, down here? And I guess the way I would interpret this is, since you're following the angle of elevation going up at 28 degrees, and the chairlift is actually on its way up, you are in the chairlift, so you are covering a distance of 4,640 feet along the diagonal. So this should be the 4,640 feet. Okay, and we want to know, what's the vertical height? We'll call that x. So from 28 degrees point of view, we have a hypotenuse and we have an opposite. So we're going to be doing the sine function. Sine of 28 degrees is opposite x over hypotenuse, 4,640. And so we're going to need to multiply both sides by 4,640. That way the x will be by itself. So what you're going to type into your calculator is 4,640 times sine of 28. And you get 2,178.3, or maybe at this point you just round to the nearest whole foot, since we're dealing with so many. 2,178 feet. That would be the best answer for that problem. All right, last page of the review here, and the directions say to solve the right triangle. When it says to solve the triangle, that means you need to figure out all of the missing information. At the end, we want to know all 3 sides and all 3 angles. So, if you're trying to figure out the angles, you might be able to just subtract. We know there's 180 degrees total inside. So if we know two of them, you could actually just do 180 minus 90 minus 50. And you would realize that angle V is 40 degrees. You could also just do 90 minus 50. Since this angle's already 90, you know these two have to add up to 90. So right away, you can get that answer. Angle V is 40 degrees. But we still got to come up with the other sides. So now we're going to do the type of problem that we've been doing. You're going to pick an angle to go from. I'll just go from 50 degrees since that's the angle that was given. And we need to use 21, which is opposite of 50. And we need to figure out both of these, so just do one at a time. Maybe I'll start with MD. If you want to give it a letter, like X, you can. And so that's the adjacent side. So that would be tangent. Tangent of 50 equals opposite over adjacent, so 21 over X. We can make the switch with the X because we don't want it on the bottom. So X equals 21 over tangent of 50. And then I'll just type that in. And I get 17.6. So yeah, if you want to just make up letters like X or Y, you can do that. Just make sure, if you're going to tell me that X equals 17.6, make sure you put X somewhere in your diagram. If you didn't have this X right here, I don't know what you mean by 17.6. Which side is that? Is that this side or this side? So if you put in a letter, make sure you actually put it in. All right, let's figure out VD, or you can call that Y. I'll just call this one VD here. So let's use 50 degrees again, and this is the hypotenuse. So if you want to use hypotenuse and opposite, that would be the sine function. So sine of 50 equals 21, which is opposite, over hypotenuse. I'll just call it VD. And we'll need to do a little switch here to get VD by itself. So we'll do 21 divided by sine of 50 degrees. And that equals 27.4. So side VD is approximately equal to 27.4. Again, if you would rather call that Y or Z or some other letter, that's totally fine. All right, here's another solving one, number 37. Okay, we don't know the angle right away here because there's two angles we don't know. But you could figure out this third side. This would be the hypotenuse, right? You could figure that out right away just by using the Pythagorean Theorem. So that's one way of doing this. You could do 12 squared plus 17 squared equals Pn squared, or if you wanted to call it x, you could do that. So 12 squared is 144, 17 squared is 289. You need to add those. And when you add those, you get 433. And then, because this is still being squared on the right side, we have to take the square root of each side. So you can actually just type in square root of 433. And we can round 20.8. I know during semester 1 when we did the Pythagorean Theorem, I wanted you to find the exact answer, and I know you know how to do that now. But when we're using sine, cosine, and tangent, we're often going to have to round, so that's okay. All right, so we know that side. Now we still need to figure out the other angles, though. Like, what is angle P, for instance? And so that's where we're going to have to use a sine or a cosine or a tangent. Actually, we'll have to use an inverse sine, cosine, or tangent. So if you want to look at this from P's point of view, 17 would be the opposite, and 12 would be the adjacent. And so you could say tangent, because that's what opposite over adjacent is. Tangent of P equals 17 over 12. But what is P? For that, you would need to do inverse tangent of 17 over 12. It's like you're asking, what angle has a tangent of 17 over 12? So you type that in, and you get about 54.8 degrees. And now, to come up with the last angle, angle N over here, for that, you could just do 90 minus 54.8. And we'll have to round that, and you get 35.2. So the measure of angle N is approximately 35.2. Because even though we're rounding, the three angles still all need to add up to 90 degrees. Okay, time to talk about the final problems here. And the biggest difference with these problems, these triangles that we're looking at, these are not right triangles. These are just regular. I think this one's an acute triangle. This one looks like it's an obtuse triangle, but they're not right. So we can't just use sine, cosine, and tangent. You know, if you were going to say sine opposite over hypotenuse, well, where's the hypotenuse? There is no hypotenuse. Hypotenuse only exists in a right triangle. So that's where we're going to use these newer formulas, the law of sines and the law of cosines. Now, the law of sines, you see there are three fractions, but you are only going to do two at a time. You're only going to set up like one fraction equals another fraction. So that way you can cross multiply and solve. So let's take a look at number 38. You want to use law of sines if you know one complete angle-side pair. And we do. We do know one pair where we have the angle and the side across from it. So according to the formula, what you're going to do is you're going to do sine of that angle on top, and then the length of the side across from it on the bottom. Now you'll need to do the same thing with another set. So we'll have to do like 75 and whatever that side is. If you want to call that side X, you can, or I'll just call it AC, since that's what the side is. So sine of 75 degrees over AC. So we're only setting up two fractions. I know it has all three in the formula. That's just telling you that you can pick any of the three. We just had to pick two out of the three. So now let's cross multiply. On one side, we're going to have AC times sine of 72. And on the other side, we'll have 12 times sine of 75. And we want to get the AC by itself, so we'll divide both sides by sine of 72. And I would just type this in the calculator so that what you have is side AC equals, and then you're just going to type in 12 times sine of 75, and make sure to close the parentheses. Then you're going to do divided by 72. Even though there's a fraction bar, you're actually going to divide that. If you type that all in, you should get 12.2 when you round it. 12.2. Okay. So this side here is 12.2. So now we know two sides and two angles. Oh, you know what we could have done right away, but it's fine if we just do it now, is we could have figured out this angle. So let's go ahead and do that now. We know there's 180 degrees in any triangle, a right triangle or a non-right triangle. So we'll take 180 minus 72 minus 75, and we get 33 degrees. So angle C, 33 degrees. All right, what's missing? We have all three angles. We have these two sides. So all that's missing is side AB. I would probably just continue using law of sines with this. So if you want, we can use our original kind of control group, sine of 72 degrees over 12. And then we're going to use the angle side pair that we don't know. We know sine 33, but we don't know AB. Those are right across from each other, so when you use the law of sines, you're always setting up the angle and the side across from it. Alright, so now we'll just cross multiply. So on one side I'll have AB times sine of 72 degrees. On the other I'll have 12 times sine of 33 degrees. To get the AB by itself, I will divide both sides by sine 72. That way the AB, the side we want to know, will be by itself. So then I will just enter all of this into my calculator on the right side there. 12 times sine of 33. Make sure you close the parentheses there. Divided by sine 72. And it says 6.87, so we'll round that to 6.9. Alright, now we really have solved all of this triangle. We know all three sides, and we know all three angles. Alright, time for the last problem, number 39. And what you always want to look for in a non-right triangle is, do you know any angle side pairs? So like 118 and the side across from it. But we don't know both of those. Or 14 and angle B? No. 16 and angle A? No. So we can't use the law of sines. We're going to have to use the law of cosines here. Remember that even though there are A, B, and C in this formula, they aren't necessarily going to correspond to A, B, C in the triangle itself. What we talked about in class is that if you're going to try to find a side, let that be the side that starts the formula. So if you're trying to find a side, let it be that side. If you're trying to find an angle, let it be this angle. Well, that's the only angle in the formula. And no matter what you're trying to find, whether it's a side or an angle, these two have to be across from each other. So I'm going to find a side. The side that I don't know is right here, AB. And so that's what I'm going to start the formula off with. AB equals, or AB squared equals. And so at the end of the formula has to be cosine of the angle across from there, 118. So then, what are these in between B squared and C squared and such? Those are the two sides that you know. So we know 14 and we know 16. Doesn't matter which one you put first. So I'll just follow the formula. 14 squared plus 16 squared minus 2 times 14 times 16. And then that's timesing cosine of 18. Okay, now what do we have in our formula? We have an unknown on the left side, and on the right side, everything is known. So what I would do is type that entire right side into the calculator. We can't always do this with law of cosines, but we can here because we know every number on the right side, or we can just type it in. So I'm just going to type in 14 squared plus 16 squared minus 2 times 14 times 16 times cosine 118. And I get approximately 662.3, but that number keeps on going. So we need to take the square root of both sides. Remember that a shortcut way of taking the square root is to raise that to the 0.5 power. So you just go to the 0.5, and AB approximately equals 25.7. If you don't want to do that raising to the 0.5 power, remember that you can always just copy down all of the digits up here. You know, you could write 662.32601, and then when you take the square root, you'll just actually type all of that in. Yeah, it takes a few seconds longer, but if it's going to get you an accurate answer, that's what you need to do. Or, like I said, you can just use the raising to the 0.5 power. Alright, so now we know that AB is approximately 25.7. So now we know all of the sides. We have a few options for where we go from here. You could do the same thing now, set up the law of cosines, and you wouldn't be trying to find a side, but you'd be trying to find an angle. So you could find angle A, and 16 is across from it, so you'd start with 16 as the number that's being squared. But now we do have one complete angle-side pair. So we can now switch over and use law of sines. And most people think law of sines is easier, so that's what I'm going to do. So we'll go sine of 118 degrees over 25.7, and actually I still have this whole number in my calculator, or if you wanted you could write it down. It's 25.735644182. Since we're going to build upon that value that we rounded, you either want to have that entire number still up in your calculator screen, or go ahead, just write it down. Alright, and then we got to pick one of the angles and sides to use. So I'll just do A. And A and 16 are across from each other. So I'm going to do sine of A over 16. Alright, let's cross multiply. So on one side I'll do 16 times sine of 118 degrees. On the other side I'll do 25.7 times sine of A. Sine of A is what we're trying to find, actually just A, but we'll start picking sine of A by itself, so I need to divide by 25.7. Alright, so when you type this in the calculator, the first part you can just type in as normal, 16 times sine of 118, close the parentheses, right? But then, how are you going to divide by 25.7? What I don't want you to do is just press divided by 25.7. Because that 25.7 number is a rounded number, and we want all of the digits behind it. So, you could just type in all of the digits if you wrote them down, like we did over here. You could type in all of those, that would be good. Or, we have this shortcut where you would type in divided by ANS, which means the previous answer. The way you get ANS to pop up on your screen is you press second and then negative. It's actually printed right above the negative sign, so second ANS. That will put in the calculator the most previously used answer. So whichever way you do that, when you multiply and divide this, you should get 0.5, but there's actually a whole lot more than that, right? So it's up to you. If you want to just keep that number in your calculator, you can. Otherwise, feel free to just write this all down. So that's not our answer. What we want is angle A, and we don't know what it is, but we know the sine of A is this. So this is where you do an inverse sine. We're asking the calculator what angle has a sine of 0.548933715, or you could just do sine of ANS if that's the most recent answer on your calculator. Alright, so that's what I'm going to do. And I get 33.3 degrees as I'm rounding. So the measure of angle A is approximately 33.3 degrees. Now I know 2 out of the 3 angles, because this one's 118, angle A is 33.3. So to find the last angle, you can subtract from 180. 180 minus 33.3 minus 118. And that equals 28.7. So the measure of angle B is approximately 28.7. Alright, triangle solved. Good luck with studying for the test. If you went through this entire video step by step, I'm going to bet you're going to be very well prepared.